Given a circle intersected by two secants BC and AD, intersected outside the circle at point E. This given situation is also under the power theorem, particularly segments formed by secants. The theorem states that if two secants intersect in the exterior of the circle, then the product of the length of one secant segment and the length of its external part is equal to the product of the length of the other secant segment and the length of its external part. So if we're going to write it algebraically, based from the illustration taken from our concept, this is how it looks like. So BE, so we are referring to this segment from B going to E. If we're going to multiply it to its external part, which is CE, so this one from C going to E, that is equal to AE. So that is the segment of the other secant. So from A to E, multiplied by its external part, which is DE. If we're going to multiply them, they have the same value. So we're going to apply, and this will be our working equation taken from our illustration. So let's apply this in our given number 1. Find the length of DE, represented by variable x, wherein AD is 4, BC is 12, and CE is 3. So writing our working equation and substitute from the given. So BE here is 12 plus 3. Remember, BE here comprises BC and CE. So that's why we're adding the length of BC and CE, 12 plus 3 respectively, times its external part, which is CE, and the measure is 3, equals AE, which is 4 and x, so we're adding 4 plus x, times its external part x, so multiplied by x. So from here, we're going to simplify it. 12 plus 3 is equal to 15. 15 times 3 is 45. We will then distribute x to each term. 4 times x is 4x. X times x is positive x squared. So notice that our equation here is a quadratic equation. So we're going to arrange this or write this in a standard form of quadratic equation, that is ax squared plus bx plus c equals 0. So since one of the side is 0, so to make it 0, we're going to add negative 45 in each side of the equation. So that 45 minus 45 is 0. Then write down negative 45 plus 4x plus x squared. We will then rewrite it, or we can also interchange this to arrange our given into its standard form. So it becomes x squared plus 4x minus 45 equals 0. Now from here, we can use any method according to our preference. So we can use quadratic formula, we can use completing the square, or factoring method. In this case, I want to use a factoring method since the given is factorable. And the factor of expression x squared plus 4x minus 45 is quantity x plus 9 times quantity x minus 5. That is by trial and error. So to check if our factors are really correct, so let's multiply 9 times negative 5, so that's negative 45. Positive 9 plus negative 5, that is positive 4. So therefore, the factors are good. From here, we're going to equate each factor into 0. So x plus 9 equals 0, x minus 5 equals 0, then solve. To solve for x here, add negative 9 in each side of the equation, so x is left. 0 minus 9 is negative 9. On the right side equation, add 5 in each side, so x is isolated here. 0 plus 5 is 5. So we are going to reject negative 9, as although it is one of the values of x, but since we are looking for the length cannot be negative. So therefore, negative 9 is rejected, and only the positive value of x will be accepted. And this will be our answer, and that's the value of segment DE. In our given number 2, find the length of UT, wherein QR is 5, RS is 3, TS is 2. What is UT? So using the same concept, so this will be our working equation taken from our theorem. Our QS here is the length of QR and RS, so that is 5 plus 3, times the external part, which is 3. That is equal to US, so that is x plus 2, times the external part, which is 2. So from here, simplify. 5 plus 3 is 8. 8 times 2 is 24. Then distribute 2. So 2x. Then 2 times 2 is positive 4. So from here, we can start adding negative 4 in each side of the equation because we want to isolate x. And in here, 4 minus 4 is 0, so we are left with 2x. 24 minus 4 is 20. Finally, divide each side of the equation by 2. So that 2 divided by 2 is 1. 1 times x is x. 20 divided by 2 is 10. And that's the value of our variable x.